Hello there. Today we're going to discuss about calculus and its application to the field of engineering. Calculus is the study of how things change. It provides a framework for modeling system in which there is change and a way to deduce the predictions of such models. Engineering is defined as a profession in which a knowledge of the mathematical and natural sciences gained by study, experience, and practice is applied with judgment to develop ways to utilize economically the materials and forces of nature for the benefit of mankind. Some engineers directly use calculus in their daily practice, and some use computer programs based on calculus that simplify engineering design. So, let's try solving questions that is related to engineering and calculus.
So our question is, a vessel is shaped so that when the depth of the water in it is x centimeters, the volume of the water is v centimeter cube, where v is equals to 103x plus x to the third. Water is poured into the vessel at a constant rate of 30 centimeter cube over s. At what rate is the water level rising when the depth is 8 centimeters?
So, in this question, we are finding the change of height over time. So to answer this question, first we have to find the derivative of the volume or the V prime, which is 108 dx over dt plus 3x squared dx over dt. Next, we have to substitute 30 centimeter cube over 1 second to the V prime. Then we have to substitute the given 8 centimeter to Vx. It will give an answer of 30 centimeter cube per second is equal to 108 dx over dt plus 192 dx over dt. So if we simplify that, we will arrive at 30 centimeter cube per second is equal to 300 centimeter squared dx over dt. So now we have to find the value of dx over dt, which is possible if we divide 300 centimeters squared in both sides of the equation so that we can isolate dx over dt. Then we will arrive at the answer 1 centimeter over 10 seconds is equal to dx over dt. Civil engineering also requires calculus. Firstly, the derivation of the basic fluid mechanics equations require calculus. For example, all hydraulic analysis programs which aid in the design of storm drain and open channel systems use calculus numerical methods to obtain the results. In hydrology, volume is calculated as the area under the curve of a plot of flow versus time and is accomplished using calculus. In structural engineering, calculus is used to determine the forces in complex configurations of structural elements. Structural analysis relating to seismic design requires calculus. In a soil structure context, calculations of bearing capacity and shear strength of soil are done using calculus, as is the determination of lateral earth pressure and slope stability in complex situations. Calculus is used in mechanical engineering in such ways like computing the surface area of complex objects to determine frictional forces, designing a pump according to flow rate and head, and calculating the power provided by a battery system. Newton's law of cooling is a governing differential equation in HVAC design that requires integration to solve. So thank you so much for watching, and I hope you learned a lot.